Good afternoon. My name is Michał. I work at Ocado Technology, and I want to talk about functional programming in Java and Scala. I will mostly show Java code, and also I want to show some Scala snippets and compare them with Java snippets side by side so that you can see the difference. And I will be honest, so I want to talk about functional programming, but I don't want to talk about any math. I won't show you any math. I won't explain why monad is a monoid in a category of endofunctors. I don't want to explain or try to convince you that functional programming is cool either. What I want to do is to show some applicable and practical examples of functional programming so that it's another tool in your tool belt, okay? So imagine that you are part of a remote team that does contracts for various clients around the globe. And one day, there's a new client that approaches you, and he has heard about this thing called Twitter that people on Earth use. And he wants to have something like that in his own galaxy far, far away. So immediately you think that you should accept this offer, and you do so, and you suggest that you will have a working prototype by the end of the next week. So you immediately go to your favorite coffee house and start hacking right away. Right? It turns out that the first functionality that you want to implement, the MVP functionality, is a followers functionality. So your application needs to show how many followers does each user have. And of course, since you are programming in a coffee house, you want to do functional programming, right? But what does it mean to be a functional programmer anyway? Probably most of you know the answer. Usual answers are like using immutable collections, creating immutable types and working on them. Of course, functions, and pure functions most preferably, and functions that take functions as parameters and return functions, so higher order functions. And we have lambdas and streams in Java 8, right? So we can do functional programming, right? Well, yes and no. Lambdas help a lot because they bring functions to the language. Streams are a nice higher level function kind of API, a little verbose, but it's still okay. The major problem is that the rest of the API in Java hasn't changed. So we still have mutable collections. We still have to deal with things like very verbose streams. And this is the real problem. So we need, for example, in order to have immutable collections, we need Guava or something like that. So the same thing cannot be said about Scala. In Scala, everything is built into the language. So for example, we can create immutable types using a very nice, concise case class. And the immutable collections are built into the language. Higher order functions are all over the place. And so it's much easier to program like that. And there is also a language called Kotlin, and we can do very similar functional programming things in Kotlin. So basic patterns, basic techniques are basically the same as in Scala, but in Kotlin, on most advanced things are not supported yet, and I will touch upon that at the end of the presentation. And I'm not here to talk you into Scala or Kotlin. What I want to do is talk about functional programming. And it turns out that we can do functional programming in Java already. There's this library called Waver. Who knows what Waver is? Okay, so this has previously been known as JavaSlang. The JavaSlang library needed to change the name due to the conflict with trademark conflict with Java. So now we have Waver, and we can use ideas from Scala in Java using this Waver library. So what I will use throughout the presentation in my code snippets in Java, all the code snippets will use Waver. So after including Waver, we can do better functional programming in Java. So we have collections, we have better functions, we have higher order APIs, and we have much more types that I want to show you and techniques that I want to show you here. And small disclaimer, I'm a Scala programmer, so I picked up Waver very quickly because those ideas are from Scala. But if you have any questions, any problems with the slides or snippets, then please just interrupt me. I will try to explain better. So after including Waver, we have almost everything we need. And I want to show you how those techniques can be utilized in a real project. So remember, we were tasked with creating a Twitter for Galaxy far, far away with a functionality, MVP functionality of counting the followers. And the first thing we need to do is, of course, modeling our domain. And our domain is right now the citizens of the galaxy, because we need to have followers, right? So each citizen will have a followers, so the list of citizens, basically. And the citizen is abstract class with the name, but we have some concrete types, for example, Jedi or civilian with name Sith, or rebel with names, and of course the stormtrooper which additionally has this is cloned Boolean flag. That means when it's true, it means that it's clone trooper. When it's false, it means that there's a real human inside. So we know our domain, the five concrete types of citizen, and of course we also need to somehow fetch them from the database. So there are two functions that are implemented by our colleague on the other side of the globe, in a coffee house preferably, and there are two functions. One of them is to find a citizen by name, so getting the citizen by providing a string of name, and the second one is getting the followers by providing the citizen object, concrete one, so the list of citizens back. So two functions that return futures. This is the most important thing. They are returning futures. What is this future type? In Waiver, we have a future type which models the value that may be available in the future, or it may fail. This is a foundation of asynchronous programming. So we want to use that, but how can we deal with such a type? So let's find out by creating a simple console application first. So our console application needs to have some kind of input. So the user of the console application just inserts a name of the guy that he wants to see followers for, and of course we need to call this function get citizen by name, right? And then we just press dot in our IDE, and we can see what kind of functions are available to us. And one of them is get. And what get does is it returns a citizen out of the future context. So it's obviously something that we need to do, right? And we can repeat the same procedure by getting followers. So we are getting the followers for this particular citizen that we got, and we have done well, right? So this is a proper way of solving the issue, right? Or not? So what's the problem if this is not something that we should do? Who knows? So the problem is that future get is a blocking call. So the user thread, the console application thread, will freeze until the value is returned. So whenever the database or the connection is slow, the user thread will just be frozen and the user get frustrated. So we need to keep the user happy and not block at all. And it turns out that we can do something like that in functional programming. There's a technique that is very, very common. And what it does basically, we don't unwrap the value out of the future in this context until the value is finally needed. So we do all the transformations that we need to do on the value. We are doing them inside the context that we're in this case, future. So for example, we can map the citizen inside the future with a function that gets the citizen and returns list of citizens, a future of list of citizens. And this will execute and give us the future inside the future, right? So this is not something that we want to work on, but there is this flat map function that we can use, and we can get rid of this additional wrapping. So we get, by using a flat map, we get a future of list of citizens, and then we are mapping over with the size function, and we will get the future of integer. So there's this function that we want to really implement. It returns future of integer, right? So what can we do with this kind of function? Again, this is function that returns future of integer, and what we can this is so common pattern in Scala in functional programming. Then in Scala we have a syntax just for it, just so you know. So basically those two snippets in Java and Scala are very similar. They are doing the same thing. So for convention at the bottom is doing the flat mapping and mapping for you. So the type, again, the type is future of integer. So what we can do with this future of integer in order to transform it into integer, right? Because in line 21, what we want to do is return the integer to the application. For example, to serve it as JSON or to do it in the console application, to print it in the console application. So in order to do that, we need to use something different than .get. We need to use a for each. A for each is a function on the future that takes lambda, and this lambda gets executed whenever the value is available in the future. When it gets available, this lambda is called with this result, and we can do something with that on another thread. So in this case, in line 22, what we are doing is we are saving that into a cache. And this function as a whole is not blocking at all, because this lambda is getting called, executed on another thread, and we are returning the thing from this cache, right? And whenever there is not any value for this particular key, we just return get or else in line 25, get or else 0, we are returning 0. So user of this API will need to poll now and then in order to get the real value from the cache, okay? And of course, we also use some additional thing from Waiver. this hash map is not a Java hash map, it's hash map from Waiver, which is immutable hash map. And when you call put on it, it will return a new map, and when you call get on it, it will return this option type. This option type has two concrete subtypes. One of them is sum, and this models the value being available, so being present, and the second concrete subtype is none, which models the value that is not there, not present. So that's why the get returns option, because the value for the key that we are looking for may not be there. And this is the application. At work. So we can see that we are providing the Darth Vader, and we get 0 followers. Then we are looking for Luke Skywalker. We get 0 followers because this is the default value inside our cache. And then after getting Darth Vader again, we get 102 followers. So the real number. That's how the application works. So there are some threads going on underneath, but we didn't spawn them by hand. There's no locking introduced. So that's the power of immutability in the future. And the web application, of course, also needs to be implemented by some other colleague of ours. And he knows about this polling API. So the web application is polling every 200 milliseconds. And when it gets a real value, it's just being updated. So if the database is quick, then it should be this value should be available pretty quickly inside the application. So everything works fine, but one night our telephone starts ringing, and it's our client. He's not happy, and he files a bug report. I can't have 0 followers. This shouldn't be possible. So probably he's right, but we need to go to our desk, run our application, fire up the console application, and run the query against the production database to see what's going on. So what we are doing is we are putting Darth Vader, and we get 0 followers, Darth Vader, and we get 0 followers, and so on and so forth. And only after 10 or so seconds, we get the real number. Obviously, Darth Vader is not so patient, so we need to fix that bug, right? But what's that bug? So the thing is that the database is very, very slow. But the real problem, the real root cause here is that we don't handle this kind of situation very well inside our application. The real problem is that 0 is treated as 0 followers and there is no value yet. So one value is treated as 2 different things. So we can't really know what's happening. So in strongly typed functional programming, what we do is we usually we model everything as data. So we want to model everything as data. We want to model our assumptions about the APIs to the client. We want to model them as data also. So what we need to do is we need to change the return type, the integer return type inside our application, to something that models the possibility of the value not being there. So in this case, it's option type, right? So option models exactly what we need here. So let's change the return value, line 33. We can see that instead of integer, we get option of integer, and nothing more changed. And instead, we just do, in line 37, we just got rid of this get or else call, because get, as I said, in a hash map, returns an option, so we just do that. We just removed the get or else. So not much changed in the implementation itself. And of course, the API changed, so we need to update our web application. Right now, whenever none is returned, we just get loading, and whenever sum and integer is returned, we just display this integer. So now the user really knows what's happening. So everything works fine again, but one night our telephone starts ringing. It's our user again, it's our client again, and he can't check how many followers does Obi-Wan Kenobi have. So obviously it's a problem, because he wants to know that, right? Whether Obi-Wan Kenobi has more followers than him. So what we do, we run to our desk, and we fire up our helper application, and we run the query against production database, because why not? And what we get is Obi-Wan Kenobi is input there, and we get Obi-Wan Kenobi is loading followers, Obi-Wan Kenobi is loading followers, 30 seconds, 1 minute, we always get Obi-Wan Kenobi has loading followers. So obviously something's wrong. So what happened? What happened now? What do you think? Database is down. Okay, that also should be a case. But in this case, the database client or database design that our colleague did is throwing an exception every time the user, the citizen, is not found. Okay, so we put a string there, and whenever the user with a name that is not in the database is searched for, we just throw an exception. In this case, Obi-Wan Kenobi is misspelled, because W should be capital, right? So Darth Vader made a mistake. Probably he used the URL to change the application. But OK, what can we do about that? Of course, there could also be a technical reason, right? Timeout or connection is too slow or something like that. And also, it will throw exception. So the future will be finished with the exception. And for each, as I said before, in the for each, we provide a lambda that will get executed every time the value is successfully returned, so value in the future. But whenever there is a failure inside this future, so this future completes with a failure, this for each doesn't get executed. So our application will always have this, will not have this value inside the cache for this particular key. So what can we do with that? Of course, in strongly typed functional programming, what we do is we model everything as data. So we want to model assumptions about the API using types. And there is a type called try in waiver that does just that. So it models the computations that may fail. And again, it has a very similar structure to option. So it has two cases, concrete subtypes. One of them is success, which provides the real name, the real type that we are looking for. And the second case is failure with an exception. So we get the exception that was thrown. So let's modify the result type. In line 46, sorry, we are changing the option of integer into option try integer, and we need to somehow change the for each into something different. And there is this onComplete function that also takes the lambda, and this lambda is executed every time the future completes, be it with failure or success. So what this lambda should be a consumer that gets this type try. Okay, that's why we can just change the type of our cache, so string to try this time, and we just save in line 47. We just 48. We just save this into the cache. So this try that will get executed on another thread. So that's all we need to change. And the best thing about this kind of API is that we can pipeline all the failures. So as you may remember, we are getting 2 calls to the database inside our context, right? But we can still work inside the future context, no matter how many times it failed or not. We need to handle the failure at the end, only at the end, so only once, even though we did have 2 calls to the database. So we changed the API and updated the web application. And of course, right now, user knows exactly what's happening, because whenever some success is returned, we just display the number of followers. But whenever some failure is returned, we just change the UI so that the user doesn't really know about the problem. But yeah, it would need to go through our UX department before, but let's assume that for now it's OK. OK, so everything works fine again, but our telephone starts ringing one night, unfortunately, and this is our client again. And he's not happy with the return types that we use inside our application. But suddenly we wake up, and it turns out that it's just a nightmare. But then we just start having second thoughts about the thing that was inside our dream. And maybe this was a sign. Maybe we shouldn't be using such cryptic return types in our application. But what about this modeling everything as data, modeling our assumptions about the API as return types? We want to have a cake and eat it too, right? So that's where algebraic data types, ADTs, come into play. So algebraic data types are helping us model the more complex reality. And those are very plain types that can be either product or sum types. Product types are just like classes. So whenever you have a class with 3 fields, string, int, and boolean, you have a product type of string, int, and boolean. And sum types are more similar to enums. So there can be only one concrete subtype. So sum can be either this type, or that type. And we can, of course, mix them together. We have already seen some examples of the ADTs in our application today. So citizen is a sum type, because it can be either Jedi, Rebel, Sith, and Stormtrooper. And the Stormtrooper is a product type of 2 types, right? String and Boolean. And of course, try and option that we have seen so far are both sum types. So let's model our result type as ADT. Let's model what we want to achieve as ADT instead of this cryptic return type option try int. So we get this 4 cases, right? This is our sum type, remote followers data, and it has four possible cases. The first two cases are very simple because the first one, not requested yet, means that we haven't requested the value. And the second one, loading, we have requested the value, but we didn't see any value yet that is returned. Failed means that there was a failure and we couldn't get the value, and this error message is also there. And of course, the success case is fetched, and we fetch the integer with the followers. So that's our ADT, that's our sum type. So now our function can return a nice type, right? Line 77. So we get remote followers data. And it's a very, very nice type. But when you think about that, it's just a marker interface, right? The remote followers data is just an interface. It doesn't have anything. So the client of this kind of API, what can the client do with that kind of API? He would need to know about what kind of instance the concrete type is this instance to do anything, right? But before I answer this question, we have very similar thing in this blue highlighted piece of code here. Because what we get is we get tried followers, which is of type try, right? And try can be either success or failure. And based on that, when it's success, we need to create different remote followers data because we need to create this fetched. And when it's a failure, we need to create failed, right? So we need to decide using some technique, we need to decide whether we should create this or that type based on whether the try is success or failure. And there is this technique called pattern matching that can help us decompose ADTs. And the pattern matching, for example, when you have sum type as try in line 81, right? So try is a sum type of two types, so we need to have two cases. First case for success, second case for failure. And we have this nice dollar function that extracts value. So whenever we are inside the success case, we know this is a success. We can then decompose this product type using these extractors. So for example, we have $1 here, so we need to provide as a second parameter, we need to provide lambda that takes one parameter and returns something else. And in second case, for failure, we extract the exception, and then this exception is passed to our lambda that we pass a second argument, and then exception to string so that we can create our failed with error message. So that's how it works. The whole blue piece of code is a value of type remote followers data. So that's how it works. Okay, so now we know how to deal with the ADTs and how pattern matching works here. So we can deal inside our console application. We can deal with our own custom ADT. And our custom ADT is a sum type of 4 types, right? So we need 4 cases. And of course, we just want to transform them into string because we want to print something to our console output. So this is how it works. The first 2 cases are very simple. We just return bare strings. In the 2 cases fetched and failed, we just extract the values using this dollar thing. And just convert the integer into string, and for fail case, we just get the error message and format it in a nicer way and return it. So again, the whole piece of code here returns a string. And both ADTs and pattern matching are supported and built into Scala. So seal trait is an interface that can be defined only in one file, so you cannot extend your ADT in some other file. And pattern matching looks very, very similar, but it's language syntax. So again, everything works fine, no nightmares. But one night, our telephone starts ringing. This time it's our user. It turns out that our application has become very popular in the galaxy. It's so popular right now that it's used as propaganda tool, unfortunately. And our client, our user is part of rebellion, and he doesn't like how we count our followers. And he say that Darth Vader has too many followers because the clones are being counted as followers. So we fire up a computer and check the logic that we currently have in place for counting the followers, and it turns out we just have this .size function, right? So we just compute the size of the list and return this as the count of the followers for this particular citizen. And so this obviously is wrong because clones shouldn't be counted as followers. So it's obviously a bug, user is right. So let's change that. But first, let's see what can we use. We can use higher order function called count, which is available in in the list in Waiver. What it does, it takes a predicate lambda that returns Boolean and executes this lambda for every element in the list, and it counts how many truths were returned. So this kind of counting logic. So let's use that, and inside of this blue square or shape, let's try to implement our lambda using some kind of logic. So first create a function for one citizen, right? So this would be a function from citizen to Boolean, and this function will return true whenever this particular citizen should be counted as follower, and false otherwise. So of course, this kind of logic needs to be implemented. And what kind of tool can we use in order to achieve that? What do you think? Sorry? Pattern matching, yes, of course. So pattern matching to the rescue, and the simple case here is that Stormtrooper, whenever this value is true on the second parameter, so as you see, this dollar extractor can also be a equals pattern. So to say, whenever this is true, then we return false, but in any other case, we'll just return true. So that's how it works, okay? And of course, it looks almost exactly the same in Scala, maybe a little less verbose, okay? So again, everything works fine, but one night, our telephone starts ringing. So it's our client, and he's not happy, and he files, this time, a feature request. And the feature request. The feature is that the application has started being used as for political purposes, and we need to somehow implement a logic that will make it less political. And when we went to the website and went through the tweets that are there, we could see that some of them are rather political. So we need to implement this new feature. And this new feature is, of course, a censorship module. This will make our application less political. So the client has provided us with a list of some kind of rules or filters for the censorship module. And the one rule, for example, consists of the condition, so whether this particular tweet should be manipulated or not, and the algorithm for manipulation whenever this condition is met. And of course, we don't want to delete, we just want to slightly manipulate all of those tweets. And the client provided us with the initial list. As I said, there are 8 rules, but this list can change. And the additional requirement is that we can't modify or manipulate the tweet more than twice. So just 2 out of 8 rules for one tweet at maximum. Okay? So our first approach would be to just use if blocks, right? And some kind of mutable variable. So if is pro dark side, then we just add more dark side to it. So this is one example rule. And we need to keep an eye on manipulation, so we need to check whether we have exceeded that maximum number yet or not. And of course, when we implement all those 8 ones, we would end up with a big block of code like that, using mutable variables and many ifs. So can we do better? Of course, we can do better. In strongly typed functional programming, we want to model everything as data. So in this case, we want to model the sensor filter as data. And we can do that. We can have a sensor filter class with 2 fields. Those 2 fields will be functions. The first function should manipulate will be a function from tweet to Boolean. This is the condition, whether this tweet should be manipulated or not. And the second one is the algorithm itself, so the function from tweet to tweet that changes the tweet. And what can we do with such type? We can create a list of types, and this is a real Java code. We can create a list of all the filters that are currently supported inside our application. So you see all the initial rules are implemented. There's this one nice and then that composes the functions together, but this still is just a piece of data. It's more readable than this if blocks, but it's still just a piece of data. What can we do with this piece of data? Can we execute it? Well, we can. So in order to execute a list, we need to provide 2 things. The first one is, of course, the initial value, initial result value, and second one is this function that takes 2 parameters and return 1 parameter. So the function that will take 2 elements and turn it into 1. So in this case, we're just folding the whole structure into one value, right? So we are folding the structure, recursive structure, into one value. And in order to give you some perspective, let's try an example on ints, right? So the initial value is 0, and the function that we provide is a sum function. So the function that sums two elements. And of course, first we get 0. We are adding 4 to it because this is the first element, and this function is called for every element. So we get 4 as a result, and then we pass this 4 to the second execution of the function for the second element, and so on and so forth, and we get 13 as the output value. So we folded the whole list of 3 ints into one value using this sum function. And there is a fold left. There is the fold left function inside a waiver list. So we can see that it takes 2 parameters. First one is the initial value, and second one is by function. So function 2 that takes 2 parameters. As I said before, the first one is for the current result, and the second one is for this one particular element that we are processing currently. So fold left executes a program that we define, and the program is a list plus this function. In our case, we want to fold the sensor filter list, right? So we need to put, again, as initial value, the original tweet, and the function that we want to apply for every element, it's called apply filter, and it's a function that takes 2 parameters, a tweet and a filter, and returns a new tweet. And of course, if this should be manipulated, we return a new manipulated tweet, and else we just return the current tweet that has been passed to this function. Of course, we have this additional requirement of manipulations. We need to keep an eye on manipulations. So in order to do that, we need to introduce a new type, which is sensor status. This will still have this original tweet, but also it will have the number of manipulations that we have done so far. And we are still doing some kind of folding, but with a different function. We needed to change that and add this status manipulations check, and of course, creating a new sensor status, not a tweet. Whenever we do a manipulation, we just increment this value. So everything is final, and folding allows us to have the algorithms without any mutable state, right? Because there is no mutable state here. So this is how the whole algorithm is implemented, and you can see that the whole if block code, the big one that I've shown, is now just 2 lines of code. Sensor status, we are creating initial sensor status with 0 manipulations and an original tweet. And of course, we then folded using initial status and the apply filter function that we just implemented. So that's pure functions in full glory. This is all nice and configurable. So when rebellion starts winning the whole war, then we might just have a future switch that will exchange the current filters with rebellion filters. So that's just one change in our code. Pretty nice, right? Okay, again, everything works fine, but one night our telephone starts ringing again, and it's not our client, it's not our user, it's Uncle Bob, and he doesn't think that our code is clean enough. So what he has on his mind is that our remote data ADT is coupled together with JSON. Okay, so we fire up the computer and the IDE and see what's going on Uncle Bob's mind. So we can see that really the remote data, we just made it more generic since we are also trying to use tweets as that, but this is just our data that has 4 concrete subtypes. What we also have here is we have a second concern. So the first one is representing the state of the database cache, right? The concern number 1, and the concern number 2 is having this kind of structure being serialized to JSON so that the web application, for example, can consume that. So that's 2 concerns in one small block of code. And when you look at this kind of diagram, this is what's happening. So HTTP server knows about this remote data, this pure data that we implemented in order to represent our database cache. But since it's annotated with some JSON stuff, it also knows that this remote data is JSON, right? So this is the approach that we currently have in our application. And there's this type class pattern that can help us solve that question, solve that problem, and decouple those concerns. And how does it work? As you see, remote data remains a pure piece of data. No annotations, no subtypes, no extends, nothing at all. Just pure pure value. And HTTP server, of course, in order to serve the response, needs to know about some kind of JSON response. And the JSON response is type class. And type class is not a real class, it's just a group of types. So group of types that can be represented as JSON response. And the thing is that we can provide the evidence that some value, pure values, are members of this kind of group of types, this type class, by having some additional piece of code somewhere else in our application that the compiler can look to and check out which types are members of this particular type class. In order to see an example, let's do that. So as you see, this is some Scala code interface, pure data, remote data, what we've seen so far, no mess at all. And when you look at the implementation of the server, this is a real HTTP server, so we have followers path /string, and for each GET request, we are completing this with remote data, which is a pure value. So no JSON at all, right? Nothing about JSON. But we still get this compiler error here, and we can see that the compiler couldn't find this JSON writer membership evidence for our remote data. Okay, so the server and the compiler don't know how to handle that. But we can provide this evidence by implementing something in a different place, something like that. We need to have implicit keyword there because the compiler needs to implicitly find that for us, so we don't have to explicitly mingle those concerns, and we use pattern matching for each particular subtype. We are providing a different JSON object, right? So this is how it works, and you can see an example of fetched here. And this is kind of JSON that we can create using this kind of technique. And then the server, which doesn't know anything about JSONs, compiles fine. So as you see, we have two kind of paths, and one of them is followers, and the second one is tweets, but we return this pure data, this pure value. Nothing about JSON at all. So again, instead of subtyping and annotating, we can just use type class pattern. And this helps us decouple the concerns in our code. Okay? And this time, nobody calls us at night. We can sleep happily ever after. This was Pragmatist Guide to Functional Geekery, starring Coffeehouse programmer Darth Vader, Luke Skywalker, and Uncle Bob as guest star, and directed by future type, which models values available in the future, option type, which models values that may or may not be there, and try type, which models computation that may fail. And all of them can be treated as monads because they have flat map operation. Special effects, ADTs, algebraic data types, they help us model more complex reality, and pattern matching helps us deal with ADTs more conveniently, and type classes help us decouple concerns in our code. The screenplay is available at this GitHub repository. I encourage you to look there. All the things I mentioned here on the slides, all the code is there, and there's also a nice README that goes through all the problems again and many, many more. So you have the same application implemented in both Java and Scala. You can see also how the HTTP server is implemented in Java and Scala, so you can see the differences. This is the same library, but in both languages. And of course, pattern matching implementation, how the custom ADTs are implemented in Java, so you can see for yourselves. And remote data is a functor. Why is it a functor? How it was helpful for me to implement it as a functor. And finally, pimp my type pattern in Scala, which helped me a lot when I was implementing predicate logic inside censorship module. So please have a look at this code. And of course, there's also a reference slide for you, how those techniques are being supported and implemented in those three languages. So as you see, only Scala supports them in the language itself, but the good news is that we can have libraries for Kotlin and Java to do almost everything. So this is a very, very nice thing because we can still use our favorite programming language and do functional programming. Okay? Thank you very much. My name is Michał Płachta. This is my blog. This is my Twitter handle. I hope you enjoyed it, and thank you very much. Have a wonderful day.